Hi, my name is Hope Wyckoff, and I'd love to talk to you today about nickel, YSZ, and molten carbonate membranes that I've been researching for CO2 capture. Basically, our project has identified factory carbon dioxide emissions as an important part of greenhouse gas and climate change. So we decided that our membrane technology would be a great way for a low operating cost, low pressure differential, great for retrofitting current factory solution to this issue. There are two transport mechanisms that will allow carbon dioxide to dissolve in a nickel YSZ molten carbonate membrane. It doesn't necessarily have to be nickel, it doesn't have to be YSZ, but essentially the carbon dioxide interacts with an oxygen and is able to diffuse through the molten carbonate membrane as a carbonate ion, and then is released on the other side. This transport has been shown to be effective with palladium gold alloyed membranes. So it would be palladium gold, YSZ, and molten carbonate. But palladium is extremely expensive and gold is pretty expensive. So we wanted to know if we could do this with a cheaper metal, in this case, nickel. The first step in this process was understanding the testing setup. You can see a picture of me there in the middle, shoved back behind the machine, trying to map out the PFD that you can see beside that picture. The second step in this process was achieving a nickel plating solution that was both stable and reliable. The picture seen there is actually the nickel plating solution, plating onto membranes. The second step or third step in this process is understanding how quickly the nickel grows on these supports. You can see in the graph there that it's pretty linear in the time frame studied, which is great and controllable for our purposes. The next and final step of membrane fabrication is carbonate loading. And we wanted to know if this was heavily affected by the amount of nickel loaded. And as you can see in that graph, it was not. In the upper right-hand corner, you can see these 4 steps of membrane development: bare support, ruthenium to allow for nickel nucleation, the nickel-plated membrane, and the carbonate membrane. In the membrane performance section, you can see a graph comparing the membranes I fabricated to the palladium gold membranes fabricated in the literature. Although the nickel membranes did not perform as well as the palladium gold membranes did at temperature, it's certainly comparable. And when you consider that the nickel of these membranes can cost less than 1% of the palladium and gold that would be required for other membranes, this makes this technology very desirable for a move towards industrial applications. Thanks for listening.